Welcome back, friends. In last two sessions, we were discussing about uncertainties in network design decisions. Uncertainties are of different types. We discussed that network decisions are long-term decisions. So you need to be very careful about developing those networks where you are developing the factories, where you are developing the warehouses, where you are developing the depots, and what are the sizes of these things. And we discussed different types of uncertainties which may come because of demand, which may come because of price, which may come because of fluctuations in the exchange rate, and because of business models also. We also discussed that flexibility can be one answer for handling these types of uncertainties. If you have 3 A's in your supply chain, if your supply chain is adaptable, it can align, and it is agile. So these 3 A's we discussed in detail in our earlier two sessions, and in this particular session we will see that because the decisions related to network, these are long-term decisions. So you need to take extreme care with respect to financial aspects of these decisions. So in this particular session, we will see with the help of some numerical examples that how we take care of those financial aspects. All these things we have discussed in our earlier sessions about flexibility in the supply chain. We discussed about adaptable, alignment, and agility in the supply chains. Now, coming to long-term financial decisions in the supply chain, we will like to discuss this discounted cash flow analysis. You are making a project, a supply chain decision of making a warehouse at a location X. Now, you are expecting some cash inflows with that decision. So you have a choice whether you want to develop at X location or at Y location, and how much cash flows you will get in future 10 years from a warehouse at location X, how much cash flow you will get from the warehouse which you are making at location Y, and then you can compare the inflows of cash for X and Y, because the cost of developing the warehouse at two locations may also vary. So you will have a net present cash flow from these two alternatives, and whichever alternative gives you better net cash flow, that is obviously your choice. Similarly, you have a very common situation in this type of discussion, and whether to develop your own facility or you can develop some kind of lease agreement, or you can have some on the spot market decisions. So for the same location X, we have these multiple options. I can develop my own warehouse, I can purchase the land and develop a warehouse. I can also take a decision that somebody is offering me a lease agreement for 5 years. So I can sign that lease agreement, and it is also possible that in some cases I may not have consistent use of that facility for 5 years. So wherever there is a requirement, I can go the spot market and can see whichever option is available, I can use that for my purpose. So all these possibilities are there, and when all these possibilities are there, I need to evaluate these possibilities, and later we will also see that how can we build element of uncertainty into these decisions. So that is what we are going to discuss in this particular session. So now because supply chain decisions are in place for a long time, so they should be evaluated as a sequence of cash flows over that period. So, as I just discussed that I am planning for next 5 years, I am planning for next 10 years. So, what is the sequence of cash flows over that 5-year period, 10-year period, that is going to decide my supply chain decision with respect to network design. Now, discounted cash flow DCF evaluates the present value of any stream of future cash flow and allows managers to compare different cash flow in terms of their financial value. The point is that when we are getting future cash flows, today it is 2017, and in 2017 I am getting some cash flow, let us say 1000 rupees. In 2018 I may get 1200 rupees. In 2019 I may get 1500 rupees. So, in this discounted cash flow, I will calculate the present value of these future cash flows, and what is the total present value, of all these future streams of cash flow that I will evaluate, and on the basis of that I will take a decision about my network choices. It is very important to understand that a dollar today is worth more than a dollar tomorrow. This is a very important concept in our management, and we all know about this concept of time value of money. If today with 100 rupees I can purchase 1 kg of rice, so tomorrow with same 100 rupees I may not be able to purchase 1 kg of rice, it may be 900 grams of rice that I will be able to purchase by that 100 rupees. So, the meaning is the money today which is there in your pocket, that is more valuable than what you are going to get tomorrow. So, for that purpose it is quite possible that in absolute terms 1200 looks more than 1000 rupees and 1500 looks more than 1200 and 1000 rupees. But it is quite possible, I have not considered the rate of discounting, but it is possible that the present value of 1200 rupees is just 900 rupees and present value of 1500 rupees may be 925. So, though in the absolute term 1200 and 1500 these figures are more than 1000, but when I am talking their present value it is equivalent to 900 or 925 maybe, if I consider some suitable discounting factor. So, I need to see what is the total present value of all these future cash flow, that is my analysis of discounted cash flow. Now, for that purpose it is very simple, and those who have some knowledge of financial management and even in the classes of project management also we discuss this time value of money in greater details. Here we are just touching these aspects. Now, the discount factor is 1 upon 1 plus k, where k is the rate of return, and on the basis of this 1 upon 1 plus k becomes my discounting factor. So, for example, if I consider the value of k equals to 10%, so my discounting factor becomes, this discounting factor is 1 upon 1 plus k, that is 0.1, and if I want to calculate the present value of 1200 rupees, if I want to calculate, so present value of 1200 rupees, so present value of 1200 equals to 1 upon 1.1 into 1200. So that is the present value of this stream. When I want to calculate the present value of 1500 for this period, for present value of 1500 for 2017, so this is the present value of 1500 for 2018, and then again I will multiply this by 1 upon this discounting factor. So this is for 2018, and then this becomes for 2017. And similarly, if I have a future cash flow of 2020 of, let's say, rupees 1700, and I want to calculate the present value of this 1700 for 2017, so this will be a step process. 1700 multiplied by 1 upon 1.1 will give me the present value for 2019. Then this factor multiplied by again 1 upon 1.1 will give me the present value for 2018, and then this value, this factor multiplied by the discounting factor of 1.1 will give me the present value of this 1700 for 2017. So if I want to generalize the formula for calculation of this present value, so CT is the future value of a particular time period T. It has to be multiplied, it has to be, I just need to see this much formula, I just need to see this much formula, 1 upon 1 plus k to the power T multiplied by CT. CT is the future time, future flow of cash, let's say at the Tth period. So this is the value of that. Now I want to calculate the future cash flow for all the periods. I want to add the sum of that. So what I am doing in 2017, if I want to calculate the cash flow of all future streams, so I will add this 1000 plus this value plus this value plus this value, all these. So the generalized way of putting this formula is this cash flow for the original period, the period of starting, that is C naught, that is here, and then CTs, C1, C2 up to CT is the stream for all the period 2018, 2019, 2020, etc., and sum total of that from T equals to 1 to capital T. So this will become my net present value, the formula for calculation of net present value. So with this formula we will compare the net present value of different supply chain design options, and the option with the highest NPV will provide the greatest financial return. So that will become our option, that will become the choice for us. So now let us have some data, and with the help of that data we see that how can we use this formula for determining a supply chain decision. Now in this example, one numerical example, we consider that how much space to lease in the next 3 years, that is the question. The demand is 100,000 units and we require 1000 square feet of space for every 1000 units of demand. that is the rate of demand which is there. The revenue is $1.22 per unit of demand. Now the alternatives are, decision is to take in whether to sign a 3-year lease or obtain warehouse on the spot market. You can sign one MOU for 3-year lease, or you can have, as per the requirement, go to the spot market and whatever alternative is available, you can select that alternative from the spot market. So these are the two choices available to you. Now the cost is that if you are signing a 3-year lease, in that case the cost is $1 per square feet, and in the spot market the cost is $1.2 per square feet. Always you will find that spot market rates are higher than the lease, and the reason is also very simple, because in the lease, for the supplier as well as for the customer, it's a guaranteed agreement for a particular period of time. In case of spot market, it is not so. Today demand is there, tomorrow demand may not be there, and you are fulfilling the immediate requirements, and therefore the normal circumstances, spot market rates are more than the lease rates. Now let us see how to handle such type of question, and the rate of return is 10%. Rate of return is 10%. Now in this case, for leasing warehouse space on the spot out market, expected annual profit, when you talk of expected annual profit, so this is the annual demand, this value is the annual demand, this is the revenue, that is $1.22 per unit, that is the revenue you have, and in the spot market you are paying this much price, 1.20 for per square feet. So your expected annual profit is 2000 rupees. Now 2000 rupees you are getting in all 3 years. For all 3 years the profit is same, 2000, 2000, 2000. So you have same cash flows, C0 in the first year, C1 in the second year, and C2 in the third year. So C0 2000, then 2000 upon this discounting factor, C1 multiplied by 1 upon 1 plus k, that is 1.1, and C2 2000 into 1.1 whole square, so that is this. So the value of net present value, the total cash flow in terms of present value is $5,471. This, when you are not going for the lease agreement, you are doing on the spot arrangement for your requirements. The other alternative is you can go for the lease arrangement, and in that case, when you are going for the lease arrangement, the same revenue 1.22, that figure we are carrying from the this value, that is the revenue 1.22 per unit of demand. So same figure comes here, that 1.22 into 100,000. Now the cost is less. The cost of lease agreement is 1 per square feet. So this expected annual profit becomes 22,000, and because of this expected annual profit 22,000, you are going to have 22,000 in each of next 3 years. So 22,000 here, 22,000 here, and 22,000 here. Same rate of return you will apply, and 1.1 square, and this is the net present value when you are having the lease for 3 years. So the net present value is much higher of signing the lease is $54,711 higher. Therefore, you can decide to sign the lease agreement, and this is a very important thing, that you are signing the lease because you are getting the higher NPV. But there are, in this question, we have taken some very simple assumptions. In this question, we have taken some very simple assumptions, and these assumptions will automatically give you an idea that we should go for this kind of lease arrangement, because the cost of lease is less $1, and in that case it is $1.2. So your expected annual profit is less. Now take a situation. Now we have understood how to go about the calculation, but actually the problem will happen in that case when you are going to have different annual demand. And in that case you will be stuck by different alternatives. So let us have that situation, that in a particular situation, because now we know how to calculate the NPV again for the same 3-year period. In this case we had the constant demand for all 3 years. Now we have a varying demand for 3 years. So we are trying to build some element of uncertainty. In this particular case there is no uncertainty in demand and cost, so there is no need to think much. You can directly calculate and get the answer that leasing is a better option. But in case when we have some kind of uncertainty, so I am trying to build one case of uncertainty where we have uncertainty in the demand of the product. First year you have demand of 50,000 units. The second year the demand drops suddenly and you have a demand of just 10,000 units, and next year you have again a very high demand of 40,000 units. So these are the demand levels for 3 different years. Now when you are going to lease, in that case the space is fixed, or you can say the cost of space is fixed for all the 3 years. If I am going for a lease arrangement, so the cost of space is fixed, that is 40,000 per year. I have to pay $40,000 per year. When I go for the spot market, in that case I will take a space as per the requirement. Whatever is my requirement, accordingly I will select the space. So I will not pay constant 40,000 in case of a spot market. My demand is 50,000, so I will take slightly bigger space, and maybe at that time I will pay 50,000 as rent in case of spot market. When my demand decreases to 10,000, I will pay 12,000 as the rent, and when my demand is 40,000, in that case also I pay 45,000 as the rent. The profit per unit which I am able to generate, not exactly profit, the revenue which I am generating, let us say that is $1.5 per unit. So I multiply the values by 1.5 into 50,000, 1.5 into 10,000, and 1.5 into 40,000. The difference of fourth column and second column will give me the net cash flows in lease. This is column number 1, this is column number 2, this is 3, this is 4, this is 5. So in case of lease, I am getting the difference from column 4 and column 2. So I write these values here, and then I can also calculate the net cash flows in a spot market. This is column 6, and these will be the values of 4 minus 3. So here I calculate 4 minus 3, and now considering the same rate of return, that is 10%, I will calculate the present value of these column number 5 and column number 6, and maybe it is possible that you can do the calculation, and then you can see that it is quite possible that when you complete the calculation, in that case it is advantageous for me to have the spot market, to go for the spot market and not to go for the lease arrangement, because here you are constantly paying 40,000 irrespective of whatever level of demand is there. In spot market, I am able to adjust this, though I am paying slightly higher cost. Here the space cost may be $1 per square feet. Here the space cost may be $1.2 per square feet, and that may also vary from period to period. Initially it can be 1.2, and in the third year it can be $1.4 per square feet. But because I am able to optimize my space requirement in the spot market, which I am not able to do in the lease market, so on the basis of this net present value calculation of my all future streams of cash flow, I can take a decision that yes, it is more profitable to have a spot market. So this is one small element of uncertainty with respect to demand that we built into this case, and we saw that it is more profitable to have a decision which is going to help us in creating the more cash flow in the present system. Now going further into these things, you will further say that we need to build more uncertainties into our demand and cost related issues. So going further, we want to have the binomial representation of uncertainty, and we can have some other representation of uncertainties also. You have a price P today, and tomorrow either price can improve means increase, or it may decrease. There are two probabilities. With probability P, the price can increase, and with probability 1 minus P, price can decrease. So in our next sessions, we will see that how to build those types of uncertainties in our network design decision, and that will give us more practical insights about handling uncertainties in our real time analysis. So we stop here in this session today. Thank you very much.